Hello friends, Jove here. Welcome to another episode of the Test-Driven Development Screencast. In this video, we are continuing our work on the sign-up, and particularly we will start test driving some of the business logic, which is quite exciting for me. So make sure to set the video speed to 1.25, get ready to code along, let's get started and see how it goes. So here is my to-do list. So basically, before starting to work on something, I normally want to have a little, plan on what's gonna be like. What are at least what are the tests that I want to start off with? So basically, in this regard, for the sign up, I think we can start working on basically working with the credentials. So we can start by validating the credentials before proceeding onwards. So for example, I can say credentials validation, and for example, what it means for us to have a bad password, bad email, for example, and also a bad password. Also, then maybe what does it mean to have a valid email? Valid credentials, and then we can work on actually creating an account. What happens when we fail creating, whether we are like offline, for example, or it's just backend. And here, for example, about the backend, maybe we should not be allowed to create two accounts with same email, that kind of things. But of course, that's something we can think about as we go. But the important point for now, at least for this video, is to start working on the credentials validation. So let's maybe dig into that. So here is our tests, the unit tests here, and let's maybe start off by creating a package. I'm gonna name it sign up. And we can start off by writing our first test. And let's say that's gonna be our credentials validation test. So as I mentioned in some of the previous screencasts, in the previous series, the plan for this one was not to try to not to use mocking libraries and stuff like that, but still try to use like sort of mixture of the approaches and then see how it goes. This is sort of particularly a bit newer for me as well, so I want to learn more how this approach is gonna go, how it will end up, but also like it's gonna be, I think, nicer that we are not gonna depend on libraries like mocking libraries, and then the tests are gonna run faster, and like we have many benefits. So the idea is that we can use libraries like, for example, assert_j to make the tests read cleaner and whatever, but my idea is not to depend on, at least for the screencasts, I want to show that we can actually go with a very bare minimum. We don't need like rocket science to do the things work. But if you want to, like, we can add cosmetics like assert_j or like other libraries that are particularly nice in Kotlin or something like that. So let's get into this and start off by our first test. And as I said, first we can focus on like what happens when we have a bad email, or maybe let's say an invalid email. So let's import this. So I would expect a sign up state with let's say a bad email to be delivered to. So what I'm assuming right now, what I'm imagining in my head is like something that I spoke at the earliest, I think in the first screencast, like in both screencasts, like outside in and inside out. In terms of Android, we have now our sign up screen, and that sign up screen should send events somewhere. and then should observe state from somewhere. So that somewhere is gonna, normally on Android we use view model because it's something that is well established across the Android like modern development paradigms, and I think it's sort of something that's gonna work for us as well here. I don't want to, like, we can go with something custom and shoot ourselves in the foot, but the view models are working just fine. Why not using them? So I'm imagining something like a view model where I'm gonna send events from the UI and then observe state. So basically here what I'm trying to test is like the state of somewhere in my view model. I'm gonna expose this state that the UI can observe to, and then I'm asserting on that state. So that state should be like bad email, for example, and then it should be, let's say, my view model sign up state value. So we'll get back to this a little bit later, but the action should be, let's say, the view model create account, and then what do I need to create an account? So when we started at the UI, we have an email and a password, but I think for the sign up, maybe it would be nice if we introduce also another field like a about. So like when we are creating an account, we can just say something about us, but that can be something optional. So let's maybe take that in consideration now and see how it goes. So let's say create an account, email. This is a bad email. The email, so it is not an email. So the schema, the format does not look like an email. So then the password is irrelevant, and when I have something irrelevant, I just put it in these columns, double, like at the beginning and at the end, and then I can just type whatever. But I also prefer to have like what does it stand for. So for example, I can say password here, and also about. But as I said, they are irrelevant for this test. The email is the relevant part. So let's make this work. So as I said, my view model is gonna be a sign up view model, which does not exist yet. Then I have my act and then the assertions. So let's create a class view model that's gonna live in my production code in a sign up package, and I'll split the screen on half and then have the view model on the right side so we can see what we are doing. And then we need the create account function that's gonna be email, password, and about. I need this formatting because if I reduce the size of the code, it will be hard to watch, hard to follow. So I think let's make it bigger, and so we can see better what's going on. And then finally, let's create the sign up state. It's gonna be also a separate class. I think it's gonna live in the sign up state folder or package. And I need to create this bad email thing in there. So it will be inside the sign up state, an object, and it should derive from the sign up state. And I need this one to be a sealed class. Something like that. So that compiles, and now what's going to be the sign up state here? Let's create a member. So that's, as I said, the view model will expose something that the UI can observe upon and then render whatever the state's gonna be. So I was thinking what to use in this case. So I was thinking between there is these new things from, not actually that new, the flows, whether it's like StateFlow or SharedFlow. I was thinking about them, but then I was reading across the documentation and came up to a point where, as we can see here, I noticed that there is this note here that says that we have to be careful when using StateFlow or SharedFlow because they might work in the background. So when the view is goes in the background, the coroutine suspends, leaving the underlying producer active and potentially emitting values that the view doesn't consume, which is sort of CPU intensive thing. We don't want that. And then also this warning here, we have to be also careful, like how do we observe the things in the UI, because there is particular cases when we can experience app crashes because like the view is gone, but like the view is not visible, but there are some events coming in. So how do we work around this? We can actually deal with, like, create jobs ourselves and then initialize it on start to be able to cancel it on stop, and then, like, of course we can abstract this away into, like, let's say some life cycle abstraction that we can reuse across the project. But the thing is that why complicating the things in order to do something that it's not really required at this point of time? Like, we can use the LiveData, and the LiveData is something that already works and it's not deprecated, so I thought let's maybe just use what we got. So as I said, we are gonna have LiveData, and that's gonna be of type sign up state, and I'm just gonna initialize it with a mutable sign up state. And a mutable sign up state is going to be a property that I will initialize to mutable live data, also sign up state. So basically this one is private, so I can modify it here, and this is something that I will expose, but because the return type is live data, nobody can really mutate that one. So I can mutate only the mutable, and it's gonna be happening here. So now I think I have the test compiling. Let's run and watch it fail. So the operation is not implemented, which tells me that we are hitting this code here. So if I remove, I should have a failing test, which is great. And how do I make this work? It's like all I can, like the idea is now that I have to like fake it till I make it. So I can just hard code the value here, and I can say that it's sign up state bad email. So I want to make this test green as soon as possible, so as fast as possible. That's the idea, and then I can do on refactoring. Okay, now we have another problem, which is the looper. So basically in JUnit 4 we had that rule, but now I'm using JUnit 5, so I need an extension, and because I don't have it, I have to create one. Extends width, and then the extension that I don't have would be called, let's say, InstantTaskExecutorExtension. So I don't know if there is already an artifact that I can pull to use to use something like this for JUnit 5, but because I'm not aware of any, I can just create one myself. So create a class, and I want to keep it in my unit tests, but I want to keep it in the root. Okay, so what I need here is I can just derive from the before all callback and the after all callback, and these are basically the callbacks that when I run some tests, I need the events before all the tests run and after the tests are running. So what I need to do is, like, I can just change the delegate for the get instance set delegate for the task execution. So I need let's say an object that is a task executor, and then I will override these functions here, and then I'll just say runnable.run, here as well as here, and here I'll just return true, saying that yes, this is the main thread. And in the after, I'll just set the delegate. I will just reset it, set it back to null. And now, if I run, I should be green. Cool. So let's maybe check this in first. And I would like to split these two commits. First one, this. I would say introduced a task executor extension for LiveData, and then this one's gonna be can detect invalid email as long as the email equals to email. So as long as the email is particular value of the email is email, I can detect it as a bad email. And now let's also here delete this example unit test because we don't need it. And then I can also check that one in. Removed an irrelevant test case. Cool. And now I can work on triangulation to actually see how I can deal with how can I actually make this email detection algorithm better. But the thing is that because this is email and it has to comply to particular format, I can actually triangulate till tomorrow and never have enough. So what I'm thinking is actually I can make parameterized test and extract this as a parameter of this function, then change this into parameterized test, and then as a source I can use CSV source. And then what are the emails that are not gonna be valid, let's say. So let's come up with a bunch that are coming now in my head. So the one that we used to have before was email. Then I think I need some sort of to work with. So this is gonna be, let's say, a at b.c. This is the email schema, but I think that I need at least some minimum of characters on each side. So I think one is not enough. I need at least two. So let's maybe cover those situations. So for example, a is 1, bc. So what if I have a b, then c, then what if I have a b, b, c, and then c? It should be also not valid. But if I have like at least two characters here and here, and then after the dot, it should be valid. And maybe also, let's say, an empty or a blank one. Yeah, I think that's something already good enough. Let's run. It should fail, but it doesn't because I'm already covering that here, and I'm good. I can just check that in and call it a day. So here I can say can detect different invalid email formats. Cool. And then I think here we covered the bad email, but I think I would like to also put these credentials validation in the, so here in the README as part of the because this is the README will be used as documentation. I would like to include this what's happening here, so what's going to be the logic for the bad email, and that's something that I can do off camera because that's not very interesting. But I can say that this one is done, and then I can continue with a bad password. So let's write a test for the password, and I would say invalid password. So assert equals sign up state bad password would be the view model sign up state value. And now the view model is going to be my sign up view model, and the trigger would be also create account, but now I need a valid email here. Say I don't know, anna@friends.com. Then I need an invalid password, which is, let's say, an empty one. And now also about is not relevant. So this is an invalid password, right? It's just empty. Let's create a bad password in a sign up state, and that should be also sign up state, and run. Watch it fail. Cool. Now it fails because we return bad email, but we are expecting a bad password. So now let's make that work. So now, instead of actually going into all these baby steps in order to make sure that I'm covering email, like, checking how many characters are in front of the ad, and then after the ad, whether I have ad and dot and blah, 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 I can use regex to actually get to that sort of faster. And I already have a regex that I can use, but we can go through that and we can see what are the important parts of the regex. So I can say, for example, val email regex, and that's gonna be this here. Well, I think, yeah. So now let's see what we got. Here we are expecting letters, small letters in the range from A to Z, then capital letters in the range from A to Z, and then numerals from 0 to 9, and then some characters like plus, dot, underscore, percent, and then it can also have a dash, but we have to escape it, so this is escape here. And then there are the boundaries. For example, we need at least so the one is the low boundary, so like it should be more than one character, more than one character, and then up to 64. Then we expect an at, and then after the at, the first character must be either character from A to Z, either small or capital one, or a number from 0 to 9. And then the other characters can be, again, the same, A to Z small or 1, or a number, but also we can accept a dash. And again, the boundary should be like 1 to 64. And then afterwards, we expect a dot. So there must be a dot, also escaped here with this slash. Then again, the first character after the dot must be either a letter or a number. And then afterwards, we can again accept letter or number or dash. And then again, it should be at least 2. So basically, minimum 1 is the lower boundary. And that's our email regex. And now out of this regex, we can create a pattern, which is gonna be a pattern compile email regex. And then we can say if we have the email pattern matcher for the email, is not matching, so basically that's this exclamation here. If it's not matching, then we deliver as a value a bad email. Else, if our password is empty, we can deliver bad password, and that should work. Cool. So let's check that in, and we can say can detect a bad password as long as it equals, as long as it is empty. That's cool. And I think now we can also do the same with a password. So I can just extract this into a parameter of the invalid password function. And let's make it a bit smaller so we can see the entire code. And then here I need a parameterized test. And then I need a CSV source. And then some bad passwords. So I think the password should be at least 8 characters. I need also one small, one big letter, and a number and a character. So basically that's the requirement for the bad password, for the good password. So anything other than that would be bad. Let's say, for example, an empty, like I think it should be like this. I don't know why I have to wrap the value into a single quote here, but that's how it works. So blank wouldn't be an option as well. Also, for example, 1 2 3 4 5 6 7 8 shouldn't be accepted. What if I have, let's say, A B C D and then numbers? What if I have A B C, let's say D E F, and then numbers? That should be also not accepted because it doesn't have any special characters. And then what if I have ABC, let's say DEF, 7 8 and then some characters? It should not be accepted because I don't have a capital case. And the same should be if I have ABCDEF. That's also a wrong one because it doesn't have now small letters. I think that's fine. I mean, if there is something that I miss, I can detect later. I can just add it. But for now, I think it's more than good enough. So yeah, now the test is failing. So let's do the same here with regex for the password. So I can say val password regex is gonna be password regex is going to be let me also copy this because I have it prepared already. And then we can go through that. So the regex says that we are expecting a string, so this is a start of a string. Then here we say that we expect at least one number, so in range from 0 to 9. Then we expect at least one letter that is small letter, then at least one big letter, so it should be in the range from A to Z. Let's see. So that was this, and then we expect at least one of these characters here. So we can also maybe include the dash, but we have to escape it. So this means that we are escaping it, but we can also accept a dash. And then we say that it should have at least 8 characters as well. And then this, so that's the low boundary. The up boundary is like unlimited, and then this one is the end of the string for the regex, I mean. So then out of this we can create a password pattern, and we can say pattern compile password regex. And what we can do here is we can say if the password pattern matcher for the password matches, so if that's not the case, then we can deliver bad password. So let's run and see. That should work, and it does. So let's check that in. Can detect different bad or unacceptable passwords. Now we can also, like if I go back here, we can say that that's done, and then what it means to have a valid email and password. But before that, I would like to actually do some refactoring here. So basically I want to pull these sort of validation out of this class. So the sign-up view model shouldn't be actually validating, shouldn't do much about the validation. It's like irrelevant for the sign-up view model. It should live in some separate class. So I want to pull it out from here, and that's a bunch of refactoring. So let's maybe start off first by pulling out the setting of this view model, and then the getting the value. So maybe let's start by saying val state is going to be this if, and then we need, it's gonna be either this or this, or else, I don't know, I'm gonna leave to do, and then we can say this. The mutable sign up state value is gonna be the state. So that should work, and it shouldn't break anything. And basically now I can get rid of this block here. So what I've done is I have pulled out, I have separated the getting the state and then assigning the state. So I can check that in. The state state assigning and delivery. So I don't know. I don't know how to name that commit better. So that's the first thing, and then another thing is that in order to complete this refactoring would be to basically I'm thinking whether it's gonna take too much time, because this episode goes already 30 minutes, whether to leave it for the next one. But basically the goal is, like, in order to separate this, I need to actually come up with different result from the validation, because the validation is going to be happening somewhere else, and it should return standalone results from the validation. It shouldn't return sign-up states because it's validation, so it should deal with validation results. So let's maybe try to actually do that in this episode. Basically what I can do is I can say val result is, I can copy this, and I can say here, instead of sign up state bad email, I can say credentials validation result invalid email. And of course this does not exist. Let's create it, and I'm gonna just create it here for now, and create So it is not letting me create automatically. I'll create it manually. So it's gonna be an object called invalid email, and that's gonna be also a credentials validation result. And of course this has to be a sealed class, and that should not break anything. But I'm not gonna commit all these intermediate steps. And then also I think this one would be a invalid password. Yeah, it's not letting me do this, but I can do it manually. And of course it should not break anything. And finally what we can do here is we can say val state is maybe, oops, I can say val let's directly change, I think. If result is invalid email, then do this. Else if the result is invalid password, then do this, and then assign, and that works. And what I can do is I can replace this with a when, and let's maybe try to remove, yeah, and also here remove. That looks slightly cleaner. So I would say state is when. I can remove this else here. That should still work. And what I can do now is, like, instead of maybe I can just directly assign here and here, and that should still work. Oops, I am no longer having the state. Because now it's a sort of unit. Let's run. Everything is fine. Let me close this, and I can remove state from here. So I think that's pretty nice, pretty clean. It's sort of just mapping, but I think it's okay. So now this mapping, I think here is okay to be part of the view model, but I think now I'm free to start extracting this logic here. So what I can do first is, like, I can make a function out of this called validate, and I can also, oops, inline this. And if I run, everything should be fine. So let's check this in first. So I would say use credentials, not use but introduced, credentials validation results. Yeah, I think that's enough. That's good. So now what I can do is I can actually start extracting this as a collaborator. So basically I'm gonna have something like a class that will be, let's say, regex credentials validator, and then I can put this thing in there, and that should not break anything. And now here I can say regex credentials validator validate, and that should still work. And now I can get rid of this function here, and that should still work. And then I can just check that in. So what I can say is extracted the validation into a separate class, and what's next is basically I can introduce this the like essentially what I want to do is I want to remove this duplication here. So this whenever I call the create account, I'm creating new instance of the regex credentials validator, which means I have a logical duplication. So I want to get rid of that logical duplication. I want to get rid of that. So I'm just gonna introduce a collaborator into the view model. In order to do that, the first step is to actually have this class outside from here. So let's actually both classes, this and this. So let's extract them outside. So this is gonna be credentials validation result, and it's gonna leave into, instead of the sign up, because they are not part of the sign up solely, they might, I mean, I'm gonna reuse maybe the same for, I don't know, login, maybe some other thing like that I might end up validating later. Let's see. So they are part of basically the domain, and then I'm gonna have a package called validation, and that's gonna be in my main source. That's what I want. And I can also do the same for the regex credentials validator. So move, and that's gonna be in my domain validation. And now if I look at my sign up view model, what I can do is I can introduce this one as a parameter for the view model. I'm gonna name this credentials validator, and I can make this private. And now there is import missing here, I guess. Yeah. And now if I run, everything should be still fine. So I think yeah, I did 2 steps actually. I should have checked in the extraction of these classes first, and then do the refactoring for introducing the collaborator. Okay, so that was a mistake, but okay, for this one, I think there are 2 steps in one. I shouldn't have done that, but okay, I mean, it happens. So I would have rolled back now twice if I ended up with a mistake, but luckily everything is there. So extracted validator into and validation results into separate package, Yeah. So first I should have done that and only now introduce this collaborator here. But I mean, okay. So now the tests should work as they did before. And I think the last thing that we want to do is the valid email and password. So let's do that as well here. So we need another test for that. So valid credentials. So I would assert equals credentials validation result valid to be the result, and then my result's gonna be a validator validate, and I'm gonna have a, let's say, John at friends.com and some password. So 1 2 a b c d 3, something like that. My validator is gonna be the regex credentials validator, and the valid is not there. Let's create it. Right, and now if I run, it should fail, and it does, because it's not implemented, because we have a to-do here. So let's go ahead and instead do this. Credentials validation result valid. And if I run, it should work. Let's check that in. And I would say can detect a valid credentials. And let's do a little cleanup here as well. So first of all, I want to inline this. Then I would like to extract this as a constant here. So that's going to be an email regex. And it says that the warning says that I should not use all capital letters here because it's not constant. So let's make that a constant. But the constants couldn't live like that. I should put them into an object. So let's create a companion object, and let's maybe make it private because it's relevant only in this class here. So that's what we wanted. And then I can inline the use of this email, and basically I can also pull this out and create it once, because this is also a logical duplication, because whenever we call validate, we are gonna recreate this pattern. That's not really required, so we can just pull this as a property. So I don't know why there is not simple way to do this. The studio is always creating all these ceremonies, but basically this is what I want. So I need to make that, oops, I just need to make that private, I guess. No, I want to make it private. That's what I want. And now I can just get rid of this line. And if I run, everything should be working fine. And I can say that well, maybe do the same for the password, and as a one bigger step, I think that's fine. That's gonna be my email, sorry, the password password regex. That should be also constant. I'll pull it up into here. And I would also inline this one and pull this one as a property. And make this private. And if I make the code a bit smaller, I think that's what we want. So we have a little companion object that hosts the two regex constants. Then we have two patterns for email and for password. And then here, I think I don't need this line any longer. We came up with pretty much clean function here. And everything works, so we can check that in. And we can clearly name this removed duplication. And I think that's pretty good spot to be. And now this when is actually making a warning because there is there is a expression that is not handled here, which is the what happens when we have valid results. And that's gonna be something that we will be working on the next episode, because I think for this one we are done, because we have the credentials validation, we've completed that part, and I think it is also we are running a bit over time. It's like already 50 minutes, rarely happening in this screencast, so I think that's gonna be enough. And let's keep the episodes from the next one shorter. So yeah, I think hopefully that was interesting one. So yeah, I'm gonna catch you in the next episode. Thanks for watching. Bye bye.